single researcher uncovered an invisible energy that would eventually map the human skeleton and treat aggressive cancers. But the thousands of hours spent handling this glowing force slowly destroyed her own body. How far would you go to pursue an answer, and what personal cost would you accept to bring that answer to light? Marie Curie holds a distinct place in scientific history. She is the first woman to receive a Nobel Prize and the only person ever to secure the award in two separate scientific fields. Her career was defined by a lifelong willingness to endure severe personal hardship for the sake of scientific truth. Born Maria Sklodowska in 1867, she grew up in Warsaw, a city firmly under the oppressive control of the Russian Empire. Under this regime, Polish culture was suppressed and education was heavily restricted. For women, attending university was entirely illegal. She refused to accept this limitation. She secretly attended illegal underground schools, risking severe punishment to study forbidden scientific concepts. Knowing she needed formal training abroad, she made a pact with her sister. They would fund each other's education. Maria spent years working in isolation as a governess, saving every spare coin. When she finally arrived in Paris to enroll at the Sorbonne, she survived on a sparse diet of bread and tea, studying endlessly in a freezing apartment to master physics and mathematics. Enduring the systemic denial of her basic rights in Poland had hardened her resolve. She arrived in the laboratory with the extreme determination required to challenge the boundaries of known science. This intense drive drew her to a physicist who shared her absolute devotion to inquiry, Pierre Curie. Their attention was soon captured by Henri Becquerel. He had recently discovered that uranium emitted invisible rays, a strange anomaly that much of the scientific community ignored. Marie became entirely absorbed by this mystery. She abandoned conventional research paths to figure out exactly where these invisible rays were coming from. Her initial tests revealed something profound. The energy wasn't the result of a chemical reaction. It was coming from deep within the atom itself. She coined a new word for this behavior: radioactivity. Major leaps in human knowledge often start when a single observer takes a dismissed anomaly seriously and follows it to the source. To prove her theory, Marie and Pierre needed raw evidence. They set up their operation in a drafty, unventilated shed, acquiring mountains of a highly toxic ore known as pitchblende. For years, Marie performed grueling manual labor. She stood over large iron cauldrons, personally boiling and chemically treating literal tons of heavy rock by hand. This scale shows the sheer mass disparity they faced. To isolate these unseen elements, they reduced multi-ton mounds of raw earth to a microscopic fraction of a single gram. Within that tiny yield, they identified two new elements. She named the first polonium, defying her homeland's occupiers, and the second, radium. At the time, the scientific consensus stated that atoms were solid, indivisible blocks. Her extraction provided the physical evidence that atoms were divisible, decaying and releasing energy from within. In 1903, this work earned her the Nobel Prize in Physics. It was the first time in the history of the award that a woman was recognized. Isolating radium required years of exhausting physical endurance and unyielding conviction. In 1906, Pierre Curie was struck and killed by a horse-drawn carriage on a busy Paris street. Marie was overcome by profound grief, left to raise two young daughters alone. Yet she refused to abandon the research she and Pierre had started. She took over his academic post, breaking another massive societal barrier by becoming the Sorbonne's first female professor. Working entirely alone, she continued to process the lethal materials until she successfully isolated pure radium metal. This solitary achievement earned her a second Nobel Prize, this time in chemistry, in 1911. This second prize validated her work as an individual scientist, proving she could master the most complex chemical extractions without her partner's collaboration. When World War I erupted, she mobilized her science. She developed portable X-ray units designed to help military doctors quickly locate shrapnel in wounded soldiers. She drove these vans, nicknamed Petite Curies, to the front lines herself, allowing surgeons to perform immediate, life-saving procedures directly on the battlefield. But the scientific community did not yet understand the severe biological dangers of radiation. Decades of working over open cauldrons of toxic ore had silently damaged her body. The very elements she spent her life extracting ultimately caused her death from aplastic anemia in 1934. Today, the principles she established guide modern medical imaging and targeted cancer therapies, saving millions of lives globally. Her discoveries remain embedded in the way we treat disease and visualize the human body, a legacy of knowledge that Marie Curie sustained even as it slowly consumed her.